Hello, welcome to KAJOS Consultants. My name is Joshua, and today we are going to look at how we can run or analyze and interpret the one-way ANOVA results that we find from this analysis. In our previous tutorial, we look at what are some of the assumptions of one-way ANOVA. Said that one-way ANOVA simply compare means between independent groups so that it can determine where the associated population means are significantly different from each other. In the analysis and interpretation, go to simply look at how can we analyze the data in SPSS, and secondly, how can we interpret. But before that, always ensure you have to come up with a problem that you are solving for this particular analysis. So we have, for this case, we have got one independent variable and a dependent variable. So our independent variable for this case is going to be different locations, whereby you have classified this particular data into 3 locations, location A, B, and C. We are simply going to investigate the individual commitment, how they vary in terms of reporting criminal cases across such locations. And for that case, we are going also to test the hypothesis. And here you have formulated one hypothesis, which is a null hypothesis, stating that there is no significant difference on individual commitment on reporting criminal cases across different locations. So let me take you directly where the data is. So this is the data we are going to use. For the variable view, we have a location here with 3 groups. You have a location A, B, and C. And then you have the commitment, which has to be a continuous data, either ratio or interval data. For the group 1, or for the independent, this is a categorical, whereby it can be nominal or ordinal. For this case, we are going to have here as a nominal scale for that particular part of analysis. So to analyze this data, also have to simply go to analyze menu in the SPSS main menu and click on analyze to display the list here, and then go to compare means, which will then activate another section or submenu where we have the means, one sample t-test, and all this. And for this case, we're going to click on one-way ANOVA because this is what we are focusing on for today. So when we click on one-way ANOVA, the one-way ANOVA dialog box will be activated. And here we have the 2 variables, location, which is the independent, and the commitment level, which is the dependent variable. So independent variable can also be known as the factor variable. And for this case, our location will be moved to the factor dialog box for the one-way dialog box. Then commitment level, which is the dependent variable, will be moved to the dependent list. So that way, then you're going to check on, so for this case, we can have descriptives. Then we can have also test for homogeneity of variance. Yeah, we can leave it at that part for now. Then we can test if the equal variance is not assumed or if the equal variance is assumed. And we are going to focus on that. Then click on OK. So if we click on OK, this the output view will be generated or activated. And here we have the means and even the n values entry for each location and the mean. So we found that location A had the most number of respondents. That's why we have also the higher mean, and also even its standard deviation is higher compared to the rest. So test of homogeneity of variance. For this case, we're simply just going to see if it is significant. And you know that our significant level, let me just show you something. Our significant level for this case, we did it at 0. Compare means one way. So we can check on the options. Can check on the post hoc, and we can see this analysis is constantly, by default, it is a 0.05 significant level. So for this case, we are seeing that the test of homogeneity of variance, we are finding our value to be a significant value of 0.035, which is slightly lower than the 0.05 significance level. So this is through the Levin statistics. And what does this value tell us? When you find a Levin statistical value that is significant or lower than the 0.05 significance level, then you will make a conclusion that the homogeneity or equal variances are not assumed. Equal variance is not assumed because the Levin statistical significant value is less than the 0.05 significance level. So for that case, I'm going to tell you what to do, and just by a way of making some explanation on that. So when you find that the significant or the Levin statistic is significant, then the equal variance is not assumed. And in this case, you can do a post hoc analysis through going by the equal variance not assumed, either done at T3 or the done at C. So those are the mostly recommended ones so that you can get appropriate value for the one-way ANOVA. If we come to the ANOVA table, so we find that significant value is 0.097 between groups. So between groups simply means, is there any significance relationship between group A and group B, between group A and group C, or between group B and group C? So that's why we are finding here the significant value. There's no significant value between groups, and in this case, we can still leave it at this point. But if you want to interrogate further, then you can still do a post hoc analysis to verify how the significance of such values exist between those groups. So let's now go and do a test on this. We can still go to the analyze menu on the SPSS main menu, compare means, then one-way ANOVA. So our values are already been indicated, our variables in their respective variable list, and that one will remain the same way. Then you can do a post hoc analysis, and we find that the Levin statistical value was significant, which it was less than 0.05. In this case, we can conduct done at T3. If it was not significant, the Levin statistic was more than 0.03, then we could have done use the option of equal variance as assumed by using the Bonferroni, Tukey, or Scheffer. So those are some of the three options which can give you the most appropriate value in the event equal variance are assumed. So we can simply click on OK. Then click OK. So we find that this value, then for this case, now we can find the multiple comparisons when you do a done at T3, and we find that if you check across all these, none of them is significant because all the significant values here are more than 0.05. So for that case, we can say that there was the level of significance between groups. There was no level of significance between groups as indicated in the ANOVA table, and even after running a multiple comparison using a post hoc test. Then we can then have all these tables. Then we copy them. We copy them and bring them here. Then we just paste them here. Then we can now go to the interpretation part. And this case, we can see the hypothesis test is individual commitment or reporting criminal differs across locations. And for this case, we had 3 locations, as I alluded to earlier. The participant is divided into 3 locations. So location A, B, and C, and those one, as per the groups, I divided them into those groups. The ANOVA results then suggest that the individual commitment across scores across location differs insignificantly. So across the group, you can see they differ insignificantly because the significance value here is more than 0.05, since our value is 0.097. So it differs significantly. Then we have the F value. So after writing the F value, then you have to have a superscript, which will now indicate that you have also 2 degrees of freedom, one between groups and one within group. So the difference on the degree of freedom for between groups was 2, and the other one was 20. So we have an F value, then you have a superscript here. For the first degree of freedom between groups was 2, and then groups was 20. Then we have our F value, which is 2.612, as it is here, 2.621. Then our P value is 0.097, which is more. So we can then further move and talk about the Levin and the net T3, as I indicated earlier. So since the Levin statistic is significant, the variance is not assumed. That was the equal variance is not assumed. I also explained that earlier. The equal variance is not assumed. And in order to check for individual between groups, a post-hoc comparison using Daniel's T3 was selected, and the test indicated the mean score between the group was not significantly different from each other. So they were not, or they were significantly different from each other at 0.05 significant level. This is also clearly indicated in the table that we had. Thank you very much for your watching this video, and also for your continuous support. Kindly find time to subscribe to this channel for more updates.